Hello again, everyone. Welcome back to Module 3, where we'll be diving even deeper into cognition. Today we're exploring a topic that sparked countless debates, shaped education systems, and even influenced career paths: intelligence. But before we jump into that, let's do a quick warm-up of our previous lecture. In the last lecture, we discussed cognition as the process involved in acquiring, processing, and organizing information. Which of the following is not an example of cognition? A. Planning a driving route. B. Feeling sad after a loss. C. Solving a math problem. Or D. Recalling a childhood memory. If you said B, you are absolutely correct. Feeling sad is part of affect or feeling, not cognition. Let's try another one. Cognition includes mental shortcuts that we use to simplify decision making. What are these shortcuts called? A. Schemas, B. Algorithms, C. Scripts, or D. Heuristics? The answer is D. Heuristics. These are like mental rules of thumb that we use to save time and mental effort. Great work. Now remember, cognition isn't just about thinking, it's about how we use our mind to model and interact with the world. So in today's lecture, we'll be trying to answer the difficult question of what is intelligence? We'll look at theories of general intelligence, multiple intelligence, and emotional intelligence. Then we'll wrap up by looking a little bit at comparative cognition, how we study animals and compare their cognitive patterns to ours. Then we'll review and finish up. Right, let's start with a reflection by getting a little personal. Do you think that you're smart? How would you describe your strengths? Are you great with numbers? Are you creative with words? Are you athletic? Are you musically inclined? Intelligence isn't just about being good at math or solving puzzles. It's about how we understand and navigate and adapt to the world. Today, we'll explore what psychologists mean when they talk about intelligence. We'll examine how we measure it, the different ways it can show up in our lives, and even how animals demonstrate cognitive abilities. Along the way, we'll see how intelligence is a model, a framework that we use to understand and predict behavior in ourselves and others. To start out, what is intelligence? Now, defining intelligence might seem simple at first. After all, we use the word all the time. But how do you define it? What does it mean to be intelligent? Psychologists have grappled with this question for decades, and their answers show just how complex intelligence really is. At its core, intelligence is about adaptation. It's the ability to learn from experience, solve problems, use knowledge to navigate the challenges that we face. But even this definition doesn't seem to fully capture the many ways that intelligence can manifest. Let's reflect again. Think about how intelligence shows up in your own life or the people that you admire. Is it their creativity, problem-solving skills, emotional awareness, ability to connect? Keep these thoughts handy because we're going to be revisiting them as we go deeper. Why is defining intelligence so challenging? Part of the difficulty is that we often don't think of intelligence as a single thing. It's a model we use to explain a wide range of cognitive abilities. One psychologist might focus on reasoning and problem solving, while another might emphasize adaptability or creativity. We have to agree on what we are even studying to come up with a unified definition. One perspective on intelligence is the idea of general intelligence. What do you think connects the ability to solve a tricky math problem with remembering the plot of your favorite TV show? On the surface, these seem to be very different skills, but psychologists have argued that there's an underlying factor, something called general intelligence, or G, that ties everything together. G is the idea that there's a single overarching factor that influences our performance across a wide range of cognitive tasks. This concept was first proposed by Charles Spearman in the early 20th century. He noticed that people who did well on one type of mental task, like solving puzzles, tended to do well on others, such as understanding complex instructions. From this, he concluded that there must be a shared underlying ability influencing their success. One of the ways that we try to measure G is through IQ tests, or intelligence quotient tests. These tests assess a person's cognitive abilities and compare them to others in their age group. A higher IQ score suggests a stronger general intelligence, which in theory means better problem solving, reasoning, and learning skills. But IQ tests aren't perfect. There's a few limitations. They come with cultural bias. Test questions may favor certain cultural or educational backgrounds, making it harder for people with different experiences to score well. They also don't take into account test anxiety. For some people, the stress of being tested can lower their performance, even if they are highly capable. These tests also have a narrow scope. While IQ tests measure things like reasoning and verbal skills, they don't quite capture creativity or emotional intelligence or other types of abilities. Now, while the concept of general intelligence has been influential, it's also faced significant criticism. Critics argue that intelligence might not be one unified ability, but rather a collection of distinct skills. For example, someone could excel in mathematics but struggle with interpersonal communication. Does that mean that they're less intelligent, or maybe that they're just intelligent differently? This debate sets the stage for our next topic, theories of multiple intelligence, which challenge the idea of a single factor driving all cognitive abilities. So far, we've talked about intelligence as a single overarching factor that influences all of these abilities. But what if intelligence isn't one unified skill at all? What if it's more like a toolkit with different tools for different jobs? This is the idea behind Howard Gardner's theory of multiple intelligences. In 1983, Gardner proposed that there are multiple distinct forms of intelligence, each representing a unique way of interacting with the world. Gardner's theory included 8 primary intelligences: logical and mathematical intelligence, which is the ability to reason, calculate, and think abstractly. Think of scientists, engineers, or mathematicians. Linguistic intelligence, which is skill with languages, whether it's with writing, speaking, or understanding. Writers, poets, and journalists often excel here. He then had musical intelligence, which is sensitivity to sound, rhythm, and tone. This is made up of musicians and composers. He talked about spatial intelligence, which is the ability to visualize and manipulate objects in space. Think about architects, designers, or even chess players who rely on this. He included bodily or kinesthetic intelligence, which covers coordination and physical skill, which is seen in many athletes, dancers, and surgeons. He included interpersonal intelligence, which includes understanding and interacting effectively with others, like teachers, counselors, or leaders. Next was intrapersonal intelligence. This included self-awareness, the ability to understand one's own emotions and motivations. And this was something that's very key for personal growth. And finally, he included naturalistic intelligence. This covered recognizing patterns in nature or working well with plants, animals, or the environment, like biologists, farmers, or conservationists. Now, while Gardner's theory offers a more inclusive view of intelligence, it's not without its critics. Here's some of the main concerns. First is overlapping skills. Some critics argue that many of these intelligences are closely related, making it hard to separate them. For example, is a poet's skill purely linguistic, or does it involve intrapersonal intelligence? Then there's the issue of where do we stop expanding? Some people worry that if every skill or talent counts as an intelligence, the concept might lose its meaning. And finally, there's a lack of empirical evidence to support this view. Unlike the G factor, which has a lot of evidence to support it, Gardner's theory hasn't really been rigorously tested or widely supported in psychological research. It's mainly an idea that seems like it makes sense. Now, to cite these critiques, Gardner's model highlights an important idea. Intelligence isn't necessarily a single number or a score. It can be a multifaceted framework that helps us understand human potential in all its diversity. While some researchers emphasize the unifying model of G, others, like Gardner, try to focus on a variety of different ways that intelligence can manifest. Let's reflect again. Take a moment to think, how would you design a test that evaluated multiple intelligences? How would this be different or similar to an IQ test? It can be challenging to think about standardized methods for evaluating each of the different types of intelligence under Gardner's model. So far, we've explored intelligence as a model for understanding cognitive and practical abilities. We haven't discussed where emotions or being able to respond to someone expressing emotions can fit into this big puzzle of intelligence. That's where something called EQ, or the emotional intelligence quotient, can come into play. Emotional intelligence goes beyond traditional IQ. It's about understanding and managing emotions, both your own and those of others. Daniel Goleman, one of the key figures who popularized EQ, describes it through 5 key dimensions. The first is self-awareness, recognizing your own emotions and understanding how they influence your thoughts and actions. Second is self-regulation, managing your emotions effectively, staying calm under pressure, and avoiding impulsive decisions. Next up is motivation, using your emotions to drive you towards personal goals and overcome challenges. Fourth is empathy, understanding and sharing the feelings of others, seeing things from their perspective. And finally, social skills, building strong social relationships, being able to resolve conflicts, and communicate effectively. So why is EQ so important? Where does it play the biggest role? Well, consider these areas. It helps in relationships. High EQ helps you to navigate conflicts, build trust, and create deeper connections with others. It can assist in group dynamics. EQ can help us to navigate many different people's emotions and help to facilitate group action. It plays a role in leadership. Effective leaders often have high EQ because they're able to inspire, motivate, and manage teams by understanding and addressing emotional dynamics. And it can assist with decision making. By managing emotions, you can think more clearly under pressure and make better decisions. But is EQ enough on its own? Critics of EQ argue that while it's important, it doesn't really replace cognitive intelligence. Instead, it complements IQ. Think of them as 2 sides of the same coin. Both are essential, but they serve different purposes. IQ might help you solve a technical problem, while EQ might help you to collaborate with a team to implement the solution. Let's put this into practice with a scenario. Imagine you're leading a team project, and a group member is visually upset about a disagreement. What's an emotionally intelligent response? A, ignore the situation and focus on the work. B, tell them to get over it and move on. C, ask them privately what's wrong and listen actively to their concerns. Or D, publicly point out their behavior to keep things professional. If you chose C, you're spot on. Emotional intelligence involves empathy and strong interpersonal skills. By addressing the issues privately and listening actively, you're showing both respect and understanding. The good news is that EQ doesn't seem to be static. It's something that you can grow with practice. Here's a few ways to get you started. Practicing self-awareness. Take a few moments each day to reflect on how you're feeling and why. Work on developing empathy. Try to see situations from other people's perspectives, even when you don't agree. And enhance social skills. Focus on active listening, or clear communication, and conflict resolution. Now that we've explored how emotional intelligence shapes our human experience, let's zoom back out. How can intelligence manifest in the animal kingdom? What can studying animals teach us about our own cognitive abilities? When we talk about intelligence, it's tempting to focus solely on humans. But have you ever wondered how other animals think? Comparative cognition is the study of how different species process information, solve problems, and adapt to their environment. The foundational idea behind this is that cognitive abilities are shaped by evolution. Different species develop skills they need to survive in their specific environments. Think about it like this. Just as animals have physical traits that are suited to their habitats, their minds are also fine-tuned for the challenges that they face. For example, squirrels are animals that rely on incredible spatial memory so that they can remember where they've hidden their food caches. Wolves live in cooperative packs. They need sophisticated social intelligence to communicate strategies and work as a team. Chimpanzees also live in social groups, but these get even more complex than with wolves. They need high levels of social intelligence, as well as even more complex patterns of thought to achieve the many goals that they experience in their lives. But studying animal intelligence isn't always straightforward. One famous example is the story of Clever Hans, a horse who seemed to perform arithmetic by tapping his hoof. At first, people thought that Hans was a mathematical genius, but researchers later discovered that he was picking up on subtle cues from his trainer. like changes in posture or facial expressions. The example of clever Hans teaches us an important lesson. While studying animal cognition, we must be careful to separate true cognitive abilities from learned responses to external stimuli. Studying animal intelligence isn't just fascinating, it also gives us insight into our own cognitive processes. By comparing how different species think, we can better understand the evolution of problem solving and social skills, how memory works mechanistically by looking at it in action across the animal kingdom. We can get a greater understanding and insights into how adaptive cognitive patterns develop to help different species thrive in their unique environments. But let's wrap up with an important point. Studying animal cognition also raises ethical questions. This is a drawing that I made of a macaque that I worked with when I was doing graduate work at NYU named LW. The experiences that I had working with primates raised a lot of deep insight into the ethical issues that can come with studying non-human animals. How do we ensure that they're treated humanely in experiments? How do we avoid projecting human traits onto them when interpreting their behavior? These considerations remind us to approach the study of animal cognition with both curiosity and care. Today, we've taken a deep dive into the fascinating world of intelligence. From the broad concept of G to the more nuanced theories of multiple intelligences and emotional intelligence, we've seen how psychologists model intelligence to understand human potential. And by exploring comparative cognition, we've learned how intelligence adapts to meet the needs of different species. To recap, we talked about intelligence as a model. It might not just be about solving problems, it's a framework for understanding a range of different abilities, from logic to empathy to creativity. General intelligence, or G, is a foundational concept that suggests that there might be a single underlying factor that supports all of our general abilities, but it's not without its criticisms. We discussed multiple intelligences, led by the work of Howard Gardner. This expanded our view of intelligence, emphasizing diversity from linguistic skills to bodily and kinesthetic abilities, but it doesn't have as much empirical support as G. We discussed emotional intelligence, or EQ. Beyond IQ, EQ highlights the importance of self-awareness, empathy, and social skills in navigating life. And we closed by talking about comparative cognition, how studying animal intelligence reveals the adaptability and evolution of cognitive abilities across species. Let's finish with a bit of review. Which of the following best describes emotional intelligence, or EQ? A, the ability to solve problems and think logically. B, the capacity to understand and manage emotions, both your own and others. C, an aptitude for recognizing patterns in nature. Or D, the general cognitive factor that influences all cognitive abilities. The correct answer is B. EQ is about understanding and managing emotions, a skill that's invaluable in relationships and leadership. According to Howard Gardner's theory of multiple intelligences, which of the following is an example of bodily kinesthetic intelligence? A, writing a compelling novel. B, solving a complex math problem. C, performing a flawless dance routine. Or D, creating a detailed map from memory. If you said C, you're correct. Bodily kinesthetic intelligence involves using physical skills and coordination as seen in athletics, dancers, and surgeons. Before we end, let's return to where we began. What does intelligence mean to you? How has today's lecture changed your perspective? Has it made you think about how we operationalize intelligence in the studies that we use to understand it? Think about your own strengths, the unique ways that you interact with the world. How does that reflect intelligence? In our next lecture, we'll shift gears to explore how memory works, another critical piece of the cognitive puzzle. We'll look at how we store, retrieve, and sometimes even misremember information. Trust me, it's a topic you won't want to forget. Until next time, stay curious, stay resilient, and above all, live life in flux. Flux out. See you in the next lecture.